Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0300, represents a random misfire detected in the Honda Accord models from 2012 to 2017, equipped with the K24W1 engine. Misfires can lead to significant performance issues and may affect emissions control. When a misfire occurs, the engine's crankshaft rotation speed changes due to inconsistent cylinder firing. The Powertrain Control Module, PCM, which is the onboard computer, monitors the crankshaft rotation through signals received from the crankshaft position, CKP sensor. If misfires exceed certain thresholds during specific engine revolutions, the PCM will set this DTC along with any associated cylinder-specific misfire codes, P0301 through P0304. Addressing misfires is essential, not only for vehicle performance, but also for compliance with environmental regulations due to potential emissions failures. In conclusion, DTC P0300 indicates a random misfire that can present significant challenges in vehicle operation and emissions compliance. Accurate diagnostic assessment and steps are vital to identifying not only the DTC, but also its underlying causes. Treating symptoms and taking preventive actions through regular maintenance greatly contributes to engine reliability, ensuring that misfires are mitigated. The systematic approach to troubleshooting outlined here provides a framework for effectively addressing misfire codes in the Honda Accord. Engaging in regular inspections and adopting a disciplined maintenance regimen ensures long-term vehicle health and optimal performance, preventing future misfire occurrences. The DTC P0300 signals that the PCM has detected a random misfire in one or more cylinders of the K24W1 engine. The main component involved is the crankshaft, which experiences vibrations every time a cylinder fires. When a misfire occurs, the crankshaft speed fluctuates rapidly, indicating an imbalance in firing. The CKP sensor is crucial as it provides real-time feedback to the PCM regarding crankshaft position and speed. Its location is usually near the crankshaft pulley, and any failure in this sensor could complicate misfire detection. Importantly, if multiple cylinder misfires are identified by the PCM, it indicates more severe engine issues that could potentially lead to engine damage if not resolved promptly. Several factors can lead to the generation of DTC P0300, primarily failure within the ignition system. This includes faulty spark plugs, ignition coils, or wiring, which can disrupt the spark necessary for combustion. Additionally, fuel supply issues, such as clogged fuel injectors or a failing fuel pump, can prevent proper air-fuel mixture delivery to the cylinders. Intake air system failures, including issues with the mass airflow sensor or throttle body, can lead to an inadequate mixture for combustion. Lastly, vacuum leaks can cause an imbalance in air entering the engine, resulting in misfires. Each of these causes should be explored during diagnosis to ensure a thorough approach to resolving the issue. Identifying symptoms associated with DTC P0300 is critical for effective troubleshooting. Often, drivers will experience a rough engine idle, characterized by an uneven feel when the vehicle is stationary. This can be accompanied by noticeable vibrations or shaking, particularly at higher RPMs. There may also be a significant decrease in acceleration performance, making it difficult for the vehicle to maintain speed or respond effectively to throttle input. In some cases, increased emissions may trigger a check engine light, notifying the driver that there is a problem that could affect vehicle compliance with environmental standards. Recognizing these symptoms facilitates quicker identification and repair of misfires. For the first step in troubleshooting DTC P0300, begin by starting the engine and increasing the RPM to 3,000 without any load. This entails placing automatic transmission vehicles in park or neutral and manual transmission vehicles in neutral. Hold the engine at this RPM until the radiator fan engages, which ensures that the engine is reaching operational temperature. Once the fan operates, allow the engine to revert to idle conditions. Observing whether the engine maintains a stable idle without excessive fluctuations is crucial, as this provides preliminary insights into potential misfire issues. This step essentially prepares the engine for further monitoring under conditions that simulate driving situations. Once the vehicle is running smoothly at idle, the next step is to drive the vehicle between speeds of 15 to 75 miles per hour for a minimum of 3 minutes. This step replicates real-world driving conditions, allowing the PCM to effectively monitor the vehicle's performance. During this time, watch for any irregularities in engine operation, such as hesitation or stumbling, that could suggest misfire occurrences. Consistency in speed helps in obtaining accurate diagnostic data from the PCM regarding misfires, leading to better identification of underlying issues. Following this part of the test is essential to narrow down possible causes that could contribute to the misfire codes. After completing the driving phase, it is crucial to let the engine idle for at least 3 minutes. This allows the PCM to finalize its monitoring and assess conditions that may have influenced the misfire status. During this idle period, monitor and check for any new faults that may have been logged, particularly any DTCs generated during the test. Additionally, consider the recent driving conditions under which the vehicle has been operating, as these can provide insights into whether a persistent issue is occurring. This comprehensive approach enables the technician to correlate driving habits with the misfire data obtained, facilitating more precise diagnostics. Once all potential issues have been addressed through repairs, it is essential to clear any stored trouble codes using a scan tool. Following this, conduct a test drive similar to the previous driving patterns to ensure everything operates correctly after the repairs. During the drive, pay close attention to engine performance. Smooth operation without any warning lights or unusual behavior is the goal. After the test drive, recheck the system for any reoccurring misfire codes. If no codes return, it firmly indicates that the issue has been rectified, reinforcing the success of the repair process. This step acts as a verification phase, essential for guaranteeing that the vehicle is once again in optimal working condition. To prevent future occurrences of DTC P0300 and associated misfires, it is crucial to implement routine maintenance checks. Begin with regular inspections of ignition components, such as spark plugs and ignition coils, replacing them according to manufacturer recommendations or at the first sign of wear. It's equally important to routinely check the fuel supply system to ensure that fuel injectors are clean and functioning optimally, as any clogs can lead to combustion inefficiencies. Additionally, monitoring the air intake system for blockages and ensuring that air filters are clean can greatly improve engine performance and efficiency. By maintaining these systems, you can help to minimize the chance of misfires and prolong the life of the engine. Please like and subscribe to the channel. See you next time.